Then basically we are learning about life of a star, and let's see. Initially we have to watch a video. After that we will come up to the section. Spiky and Bubbles were touring the universe when they saw a star. While discussing the death of stars, they had an argument. Spiky said that stars turn into black dwarf when they die. Bubbles disagreed. She said that stars turned into black holes instead. So who's right? But hold on. Before we talk about the death of stars, we must first understand the birth of stars. A star is a huge ball of burning gases, which emits energy in the form of heat and light. Let's first see how an average-sized star is born. See these huge clouds of dust and gases? Each of these clouds is called a nebula, or a stellar nebula. A nebula collects more dust and
Sir, can't hear.
Your audio.
We can't hear. Sir, we
now see
this
whether
point, a protostar
can't hear.
is a star emitting its own heat and light.
But can you hear?
Now, now can you say if you put
All right, okay, then it's great. Hurry, then bye.
But stars don't live forever. After a few billion years, the hydrogen in the stars runs out. A star then grows in size and becomes a red giant. The red giant will then cool down and begin to lose its mass. Its outer layers will begin to form a planetary nebula. Planetary nebulas are some of the most beautiful objects in the universe. This thing we can't. Planetary nebula will disperse, while its core will collapse inward and turn into a white dwarf. Eventually, the star will become a burned out chunk of very dense matter which does not emit light. This final stage of a star is called the black dwarf. See? I was right. Not so fast, Spiky. Did you know that the mass of a star determines how it will die? Stars that are at least 6 times as massive as our sun are called massive stars. Massive stars die a more dramatic death than less massive stars. They also have a shorter lifespan. Like average stars, massive stars also start out as a stellar nebula. However, their remaining life cycle is different from average stars. When the hydrogen in its core runs out, a massive star increases in size and turns into a red supergiant. With time, this supergiant becomes so dense that it crashes inward in a tremendous explosion called the supernova. At this stage, the light of the supernova explosion outshines all other stars in its galaxy. The explosion causes great clouds of gases
to fly off the star, leaving behind a super dense core. This core only contains neutrons. Therefore, it is called a neutron star. Sometimes the supernova explosion ends up as a black hole in the universe. A black hole is so dense and has such strong gravity that nothing can escape its pull. The black hole is the last stage of a massive star life. So, who was right? Spiky or Bubbles? Well, both. Spiky was talking about the less massive stars like our sun. When they die, they'll end up as black dwarfs. Bubbles was talking about the massive stars. When they die, some of them will end up as black holes.
Yeah, so that is the basic story of a life of a star. So you should have some kind of idea on that how it happens, and just go to the next slide with it.
Why are black holes black? Black holes are so dense that nothing can escape their pull. Even light cannot escape a black hole. This is why they appear black. Let's summarize. A star starts its life as a protostar in the stellar nebula. Then it stabilizes into a star. All stars are born the same way but die differently. After exhausting its energy, an average-sized star becomes a red giant, then a white dwarf, and then dies as a black dwarf. A massive star has a different journey. After exhausting its energy, the massive star becomes a red supergiant. After a tremendous supernova explosion, the star can either end up as a neutron star or as a black hole.
Yes, Pate. Yeah, so this is
Can't hear.
I think you are just aware of the situation. So what we need to understand is if it happens, if you start with the star, we know that depends on the attraction between the particles in the nebula. Nebula means it's a just like this. It's a some kind of a nebula is a it's forming of gases, dust, and very small time of particles. So with that case, because of in the space there is no other attractions, we know that in gravitational theory we have already learned if you have two masses or whatever the masses they attract into each other. So what happened here is that in this nebula area, these particles are get together into sub what you call into sub areas means like particles can be get attracted to each other, and it can be formed into this amount of a small amount of protostar or a massive amount of a protostar. It depends on how much of a particles were attracted into each other. So so this is this what you call some kind of a formation of a small or medium type of a protostar, which is exactly similar to our sun. This is just like the massive stars, just like 3-4 times of our sun. So if you start the journey of a small protostar, in the protostar, what happened here is that particles were high, very like what do you call that? They were just attracting to very high, with a very high attraction. As a result, they just form into a small amount of a mass. Because of this attraction, what happened here is that atoms also try to be just collide into each other, and it starts to burn, right? When they starts to burn, what happened here is that it starts to emit this much, and it forms into with the time being when it is happening for billion number of years. Now what happened here is these masses are getting burned out into gases. For example, like hydrogen, the nuclear fission process, hydrogen and form into helium, just like nuclear fission process occurs. So it starts to waste. During this wasting process, what you can see here now, you know that all this process happens because of the mass, because the masses are attracted into each other. During this burning process, what happened to the masses get reduces. The mass get reduces means the attraction become lower. Attraction become lower. Since this attraction become lower, now it cannot be dense like this. Simply we know that it cannot be dense like this. Then what happened here? Now this attraction is not sufficient enough to keep these masses into a center. So they will start to expand. They're trying to expand. So here you can see here the radius is small because with the higher amount of masses are there, as a result very high attraction. But when I come up to over here, the radius become wider. What is the reason? The reason is now we don't have enough mass to keep it dense like this. Because of that, it starts to expand. At an expansion, what happened here? This expand and expand and expand, just like a what happened here, just like we are what you call blowing up a balloon. It's balloon blow up, blow up, blow up, blow up, blow up, blow up. At a one extent, what you can understand is so you can see just burst in the planetary nebula. It burst, and after that, what happened here? Some meters broke into small particles called white dwarf. This white dwarf still having some amount of energy. Then what happened here? The some amount of energy still it's burning and form up into a dark black dwarf. Black dwarf means it's a very cool and there is no energy at all. Just like a burned piece of a chalk, right? So that is the lifestyle of a medium star, just like our sun. So in some kind of billion years or billion years, with the time of billion years, our sun will turn up into what? Turn up into a black dwarf, just like a burned piece of a chalk, right? Then if there's a large amount of a mass, it form a high mass star. Then if you compare these two, what you call that situations here also, when the what you call with the time being, now the masses get burned out. As a result, what you can say, they also cannot withstand the what happened? They cannot withstand the masses into a small radius like this. So they also starts to explode somewhere over here. Now you can see, if you compare with the explosion here, is that explosion of a balloon. This can be considered as explosion of a what? Explosion of a small grenade. Small grenade, or just like a bomb. Then this, what happened here in this, what we call that, during this explosion, it is turned up into a very high supernova. Supernova means it has a very higher amount of explosion and particles are spreading to a very high distance. When these particles are thrown out into very high distance, what happened to them? The center of this supernova convert into a vacuum area. Just like you can see, so just like for example, you had your friends or some kind of a friends were there with you for a vacation for like entire 1 month. So everybody left. So what do you feel? You feel so lonely. Just like you feel like so empty. I think you may, I don't know whether you have this experience. If there are a lot of people were playing with you for a long period of time, like 1 month, after that, if everybody left, what happened to them? You feel so lonely. You feel so, huh? You feel so empty, just like this, Pute. Since all the particles, because not like this one here, the explosion is very strong. As a result, particles were thrown away in a way they cannot get together further. As a result, this the what you call that center of this one becomes so empty and it is turned up to a black hole. Or sometimes you can convert into a what happened? Neutron star. Neutron star means, Pute, like just like it's compared to a white dwarf, this is kind of more energetic, just like subparticles of this supernova explosion. That is what, that is the two process. So you can say in a same supernova process, it can form both of them. Both of them means the center can be just like a black hole and the thrown away particles can be converted into a super neutron stars in some kind of a places in the space. That's a basic concept of learning this lifestyle of a uh, life of a star, right? Okay. Then let's go to the next one. So this is just like the basic idea of what do you mean by the supernova. Sorry. The supernova stars are formed in a clouds and gases and dust known as a nebula. These particles get attracted to each other and starts to form a star. So that is the same story which I am talking about with it. Depends on the mass gathered into be the small parts, low mass protostar or a heavy star, heavy mass protostar. So depends on the amount of mass get collect. It can be a small mass protostar or a large mass protostar as I mentioned over here. Right. Okay. Then Protostar. You know that protostar is a very young star that is still gathering masses from its parent molecular cloud. So that is the same thing I'm discussing about. The protostar phase is the earliest one of a process of a stellar evolution for low mass star. So in this case, what happened is stellar evolution means so the masses are get together and form into a very high dense, some kind of a core with a very high dense. So that is the starting process of that. The phase begins when the molecular cloud fragment first collapse under the force of a self-gravity and opaque pressure supposed to be core. So in that case, basically, if I just mention these fact, so the masses are attracted to each other and they will what you call at a very high speed they get together into each other and form into a small nucleus. Small nucleus is not like micro scale, it's just like our sun or like whatever the large amount of a sun. So the masses are what you call they will submerge into each other and form into a star. That is what. So this is the what do you call that advanced definition for that. Other than that, you can simply understand that masses are get together into a like what you call masses into each other and it form a very high dense protostar. Right? It's a just a simple part of a protostar over here. You can say the masses are collecting into each other. So don't misunderstand. Stars are not like exactly one sphere. Sometimes this kind of a different kind of shape of stars also there. So still these points are here. Here the density is becoming higher and high. Here the particles are kind of spread out. So these particles are coming towards the center because of this attraction. Right. Then the red giant. Red giant is the next part of the lifespan of a middle age, sorry, what do you call that, average or a medium stage of a star. So we know that if this happens for a long time now, at the when the masses are get together each other, then it starts to burn. It starts to burn. As a result, with the time being, as I mentioned in the previous slides, so now the masses cannot get together like this, not like this. It's not cannot, what do you call that, gather into a small area. Now it starts to expand because with the time being, because of this burn, the particles are getting wasted. As a result, it will start to expand somewhere like this, right? This is a supergiant star. Supergiant stars are compared to a red giant. This is quite large and very hot. So the temperature is around 5,000 Kelvin, but here it's turned up to, it can go on up to 20,000 Kelvin as well. So in this case, compared with that, it's very hot and it's kind of massive compared with the red giant. Here, it's kind of large. Okay. Then the planetary nebula. Planetary nebula means at a one stage, these masses cannot, for a small, what do you call that, small star cannot withstand the length where they, what do you call, they cannot expand further and it starts to explode. They starts to explode, and as a result, this is the planetary nebula is the explosion of a small mass, and supernova is the explosion of what? Explosion of a supergiant stars. So here the explosion is not very powerful compared to this. This is having a massive powerful explosion. Right? Here it's very small explosion. Here it's a massive explosion. Because of this small explosion, what happened here over here? It can form into a white dwarf. Still, white dwarf has some kind of energy, and this is the neutron star. Neutron star means that is the life star of that is the end life star of a massive star, and this is the almost the end part of the life of a average star. Right? Okay, this is a supernova. Then it's turned up into a black hole. The massive stars are converted into a black hole somewhere like this. So you can say the black holes are so lonely. Then what happened here? He can absorb anything which is around in his gravitational area. So any light or any other facts is absorbed into that. Therefore, if the light enters to the we later on we learn the light also having some kind of a massive property. We called it for what do you call that electromagnetic radiation, also also considered as some kind of a mass. We call it as a wave particle duality. Wave and a particles both are having this some up to some extent they're having some kind of a same properties. So when the light enters to this event, Aflal, I think I can hear you.
Black hole, where will it go?
Black hole are remaining because but it's just like this. Because it's still we don't have a clear definition of a about this black hole because you cannot do any kind of analysis in a black hole. The reason is that none of the electromagnetic radiation or radio wave, whatever the things we send there, you cannot see it there. So actually still it's in the research level what is happening in a black hole. Some of them are saying that the masses attracted into the black hole will end up with another cone of the space and it's a generation of another star. But still nobody has given a clear definition what is happening inside the black hole. Right, the black dwarf is the other part of it. Actually, this is a just like a theoretical concept. Only the black dwarf matter. Make it because black dwarf you cannot see a clear definition because it's just like it's a burnt piece of a chalk. Burnt piece of chalk is nothing inside. Just like a just like if you're burning some kind of a wood, finally it has turned up to a charcoal. Just like it's a some part of a small piece of a charcoal. So there is nothing you cannot see in a black dwarf. So all the energies were gone away. So that is the basic concept of a life of a star. So if you want to refer it further, you can just do it because we have done one what do you call that assignment based with that event. So I will just put this one as a video as well. So with that you can refer if you.
So will the black dwarf absorb things?
Sorry, Pate?
Like black hole.